student. Okay, from UPSI student, what do they think about it? So you take only 5,000 out of 21,000. So how close is that your estimate be compared to the population? Okay. Okay, so this is a little bit of recap. So we have several, uh, what do you call it? Some, oh my God, it's not coming to me. Okay, so we have several uh, words. Istilah, oh my God, what's wrong? Okay, so we have several, some sort of istilah saya sebut je lah. So I don't think song is here. Okay, you hear song? So I'm so sorry, suddenly it's not coming to me. So we have element, it's about the entity on which data is collected. Population is the collection of all element, and we have some sample is a subset of the population. So sampling is the process of collecting data from the population. Okay, so terms, that's it. Oh my God, terms. Okay, so we have two important terms in sampling, which is sample population, meaning that the sample taking from the population, and a frame. Frame is a list of element that the sample will be selected from. So we have a list of this element, okay, and how are we going to select them, okay? Okay, next. Okay, so we have another terms which is parameters. So parameter is characteristics. Okay, it's about characteristics. So let's say you want to find what are the okay, again let's go for UPSI. So let's say your study, you are going to study on the income, okay, income of UPSI staff. So income is the parameter. Okay, so you are going to study on the parameters here. So it can be age, it can be, what is it, height, it can be whatever it is that you are trying to study. So we know that population mean or mu, okay, we know that we call the mean for population is mu, and we call mean for sample is mean. Okay, we have x bar. Okay, so the symbol is x bar for mean for sample, and mu for mean population. Next, we have sigma for standard deviation for population, and s for sample. Okay, standard deviation for sample. So they are still the same thing. One mu is population, x bar is for sample. We have sigma for standard for population, and we have s for sample standard deviation. Okay, so this is a data from your textbook. Okay, so later on you can just check. You can just download and have a go with it. So if I'm not mistaken, it is not in that file. It is not calculated yet, so you can do your own calculation. Okay, you have the function. You have the formula. So the answer or the calculation that has been done for you for this slide is that the sigma or the standard deviation for the population is 4,000. Okay, and then we have mu, okay, mean, average income. Okay, average income for the 2,500 manager or the salaries is 71,800. So mu is mean, meaning that it's average. Okay, and then we have the standard deviation of 4,000, meaning that the dispersion, okay, of from 71,800 is about 4,000. Okay, next we have the data for training program status also show that 1,500 of the 2,500 managers completed the training program. So other than giving you the parameters of um, income, salaries, it is also given to you regarding the training status. Okay, whether that 2,500 employee, a manager lah, manager, employee is the same thing. Well, it's not the same thing, but it's too inclined toward the same thing. Okay, so out of 2,500, 1,500 actually has completed the training program. So the proportion P, and the proportion population is 0.6, which yang ada training, which has gone for the training is 0.6 or 60%. Out of 2,500 has gone for training. Okay, so we have here, if the information on all EAI, so EAI is the name of the company, managers is not readily available in company database, estimate of population parameter can be obtained using a sample of managers drawn from the population. So we know that 2,500 is the population. So to save time, or there are information which cannot be accessed. So let's say that out of 2,500, there are only 30 managers being sampled. Okay, in order to find out about the sample of 30 managers out of the 2,500, this is given to you. Okay, so this is more like if you want to use how to select. Okay, so this is about how to select. You have 2,500 managers. So how are you going to select that 30? Are you going for its social security number? Also, they don't have social security number in Malaysia. So if let's say that you go for age, or you go for what else? Height, weight, okay, or all are managers. Perhaps this manager are all over Malaysia, so you might want to go according to geographical, or okay, this is the one, or you can use a random number. Okay, so this is using Excel, so I'm not going to show you, you can do it on your own. Okay, so you are going to distribute random number 1 to 30. Okay, and then the random number is generated by Excel, and you can actually get the random number from uh, Excel, through Excel. Okay, and then select the 30 applicant corresponding to the 30 smallest random numbers. So let's say that we already have that random number. So N, small n, not capital N. Capital N is for numbers or number of trials or numbers. Okay, for population is N capital, and N small cap is for the size of sample. Okay, so this is what we managed to get. Okay, so there are 30 sample here, 30 managers, 1, 15, 16 to 30. So you have two parameters here. One is the annual salary, one is the training program. Okay, so we are looking at this number here. Okay, so a sample statistic that estimate the value of population parameter is called point estimator. In point estimation, the value of a sample statistic is the point estimate of a population. So don't get confused with all these terms. Okay? Don't get confused. So we have all the characteristic here. So this is what we want to find out, the salary and the training program. So we have sample number N, small n, 30. The big N, the capital N is population. Okay, numbers, a size of population, which is 2,500. Okay. Okay, so again, we have other formula, but this formula is already given to you in our earlier classes. Okay, so we have, let us compute sample statistic for a simple random sample of EAI managers, X bar. X bar means that mean. Dia saja nak guna ayat yang canggih. Okay, so what is that we're trying to find out is the mean or the average of salary. What is the average of salary for these 30 sample that we have chosen? Okay, 30 samples. So we have this one here just now. Okay, so these are the salary according to manager. Manager number 1, manager number 2, manager number 3. So all of them, there are 30 of them. So out of these 30, so we try to add up all of them, the sum of XI, the sum of, meaning that you are going, I don't know whether this is correct, you can do your own calculation later. Okay, so you add up this one here, 69,094, 70,000, add. All together, you will get the sum of XI. This one here. So 2,154,422. So that is the sum, the total salary for 30 managers, for all of them, for all 30 managers. Okay, so we have here, okay, 2154 divided by 30, because we want to find the average. Okay, so the average salary, so that is the layman's term. Okay, the point estimator of X bar. So it sounds so, to me, quite, I wouldn't say bombastic, but it's just a way, statistic. We are saying it in statistic. But if you want to use a layman's term, easier way to understand what we are trying to find here is the average salary for the 30 managers which we have picked as sample out of the population 2,500. So the average salary for that 30 managers are 71,814. Okay, so what is this one here? 71,800. So 71,800 is the mean population. For all the 2,500 managers, this is the average. So this is for the sample. Next, it is given to you the standard deviation sigma for the population. Standard deviation for the population, which is using the symbol sigma, is 4,000. So what about these 30 people here? Okay, the 30 people here, what is the standard deviation? We know the average income is 71,814. That is the average salary for 30 managers that we have chosen as sample. So what about the standard deviation? So the standard deviation, we are using this one here. So this is X bar, 71814. So what you will do is that for each of this, 69094.30 minus 71814, 73263 minus 71814, 69, and so on. You will keep on subtracting, subtract the 71814 from the salary here, which is 71814, and then we have the square. N is 30 minus 1 is 29. So what you will get is 3348. So this one is the sigma or standard deviation for the population, but the standard deviation for the sample is 3348. And finally, we have the probability. Probability of what? Probability of the for the managers that have gone through training. Okay, this one. No. This one. So the data for training progress will show that 1,000 out of 2,500, 1,500 have completed the training program. So this is the P, 0.6, the population proportion for those who have gone training, 60%. So what about the 30? So these are the 30s. So we have here yes, no, yes, no. So how many from this 30 actually have gone through the training? So you simply just go for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So out of 30, 19 have completed the training, which is 0.633. So there is a difference between the population mean and the the sample mean, sigma, which is standard deviation for population, and the standard deviation for sample, and also the P, the probability, the proportion of population, and the proportion for the sample for those who have taken the training. Okay, so there's a difference there. Okay, so that's how we actually try to find all that, okay, for sample. Okay, so we have another several other terms. Okay, one is the target population, and two, the sample population. Okay, so we have the target population is the population we want to make inference about. So for example, like I told you, okay, so the target population are all women in Tanjung Madim. So that will be the target population. Yeah, we are targeting all female in Tanjung Madim. So sample population, so meaning that how much from the female in Tanjung Madim, okay, that we take them as sample. So the example of this, we have the 2,500 and so on. Okay, so it's okay. Okay, so suppose we repeat the process of selecting simple random of 30 EAI managers over and over and over and over again. So there are 2,500. So let's say you took 30 and then you keep on doing the X bar, the S, and the P bar. Okay, so the proportion for sample, the mean for sample, and the standard deviation for sample. Okay, so you took 30 first, and then you took another 30, and then you took another 30. For each of the 30, you try and do or calculate all those things. Okay, so in the end, you keep on taking sample. Let's say in the end, you take about 10 samples, not number of sample, 10 times sample. So you took 30, 30, 30, 30, 30, 10 times. So in the end, what you will have is 300 samples. Okay, and for each one, you will have your own distribution and distribution. So in the end, what we call it as sampling distribution. All this we will call it. As a random variable, X bar will have an expected value, a standard deviation, and probability distribution. And this is what we call sampling distribution. So all these 10 sampling, this 10 sampling, and you will do the distribution, and finally this is what you will get. Okay, this is just an example. Okay. So this one here telling you that the relative frequency histogram of 500 value of X bar as shown in the figure of the bottom right approximates the sampling distribution. So this one is taking about 500 values of X bar. So 500 times. Okay, you are taking the 30 and 30, so which is more than that, isn't it? Okay, tak apa. Okay, so this one here just now. Okay, so this one is the values of X bar. Okay, you have this one, this one, this one, satu, dua. Okay, it didn't actually give you the exact number. So you have 70,000. So one of the 30 sample that you took has a mean of 70,000. Another one have 79,000. Another one have 74,000. So that is the thing lah. Okay, and this one is for the probability. Sorry, the proportion. Okay, so this one is the proportion. Okay, and in the end, what you will have is the expected value of mean. Okay, expected value of mean, which should equal to mu. Okay, so the same thing, we have the sigma for the mean. Okay, for this, so you will have that kind of what do you call it? This is the formula. Okay, and then you have the sample size of n, infinite, and this is simplified as this one. So it's okay. We will look at it later. So we have the central limit theorem. In selected random sample of S size n from position, the sampling distribution of X bar can be approximated by a normal distribution as the sample size become large. Okay, we have discussed this last week. Okay, we have discussed this last week. So you have the value of X, population 1. If you still remember, that is the uniform distribution. Okay, and then there are two more. You have the population 2, which you call rabbit-eared, and you have a skewed distribution, which is exponential distribution. So don't worry so much about this. It's just that trying to give you some understanding regarding normal distribution. So so what you will have, okay, what you will have is that it is hypothesized. Okay, it is hypothesized. I think actually someone have already proven it, so I can't really say hypothesized, but it is said that if you go the bigger, okay, the bigger your n size, small n size increase, the more normal it will become. Okay, so that is what it's trying to tell you. Okay, so you have the okay, you have here, okay, exponential. One is uniform, two is rabbit ear, and the third one will be exponential. Okay, so it is said that if your n is 2, the shape of each sampling distribution is different from the shape of corresponding population. So you wouldn't get the distribution the same distribution. But still, okay, the more you have, or the bigger your n is, okay, the sample, the bigger your sample, the more it will become normal. Okay, all right, so this is the formula. Okay, so you have the expected mean is equals to mu, which is 71,800. So this is already given to you. Okay, this is already given to you. This one here, this one. Okay, so it's given to you 71,000, not here, this one here. Okay, so 71,000, and the sigma or the standard deviation for population. Okay, Okay, so this one, it is said that the expected value of, no, I think this one. Okay, no, this one. The expected value of this one. Okay, so the expected value of x bar is actually mu. Okay, so the expected x bar mean, okay, expected of mean for all the sampling of your samples will be equals to mu, which is 71,800. Your sigma for all your samples will be equals to sigma divided by square root of n square root. Okay, and finally you will get 730.3. Okay, so don't go into detail regarding the correction factor, anything. So that one will be later. So look at this one here. Okay, so this is what we call a normal distribution. I think I have shown you last week, okay, regarding our sample distribution. So if it's a normal distribution, your mean should be right in the middle where the mode and the median is. So this is where your mean is, which is 71,800, which is also the expected value of your mean, sample mean. Okay, and it is said that your sigma, standard deviation, equals to 730.3. Okay, so now is what we want to find out. So these are all given to you. So this is what we want to calculate. So EAI wants to know the probability that the sample mean computed using a simple random sample of 30 managers will be within the 500 population mean. So we know that the population mean is 71,800. So this is the population mean given to you. So the company now wants to know whether the mean of the sample mean could be within the 500 of this. So 500 meaning that 71,800 minus 500 ke belakang. So plus minus 500. So that is what we want to find out actually. 71,800 plus minus 500. So tolak, okay, 71,800 minus 500, you will get 71,300. And then 71,800 plus 500, you will get 72,300. So what we want to find out whether we will get the sample mean within this one here. Okay, within the antara, within, okay, the range of 71,300 and 72,300. So what is the probability when we take the 30 managers salary, we will get the number of their average mean will be within this sample here. Okay, within the population mean, 500 plus minus 500 within the population mean. So how do we do it? So we are going to use our Z-score. Okay, so the formula, use your Z formula. So you will have 72 minus 71,800 divided by this. And then you also have 71,000. So you have 72,300 minus 71,800. And you will have 71,800 minus, sorry, 71,300 minus 71,800 divided by 730.3. Okay, so what you will get is that you have to find Z between 0.68 and Z negative 0.68. So let's go to our, so this is, what's this? Oh, this is T. Okay, we don't want T. We want Z score table. I think I have, did I just, this one here. So 0.68. Negative and positive 0.6. So this one here 0.6, 8, 1. Macam tu dah. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8.2483 and 0.68, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. 7.7517. So 0.7517 minus with 0.2483. Okay, betul. Asyik baik betul. Okay. So what you will get it is 0.5034, meaning that the probability, okay, when you took out sample, 30 sample, any managers, you took 30 sample and you try to find the average income, okay, the average income, and that average income falls plus 500 from the population mean, 50%, the probability is 50% you will get the average mean within the plus minus 500 of 71,800. As I said, doing the calculation is simple. You will be given formula. You will be given tables. You can calculate. But the one that I want, the one that have high marks, would be how you interpret the result. So let's say the answer, uh, the calculation is about 5 marks for this one here. Okay, for example, let's say that 5 marks. So all this calculation here will be only 2 marks. Half, 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 half there, half here. And finally you get this one here 50%. So that's it. So my question is, what does it mean? So if you did not, or you okay, then try to calculate the 30 managers average income, okay, or average salary, 30 managers, any manager randomly, you took out 30 managers and calculate the average income. The probability that average income falls within 71,300 and 72,300, okay, is 50%. 50%, there is possibility that it will fall within that. So that is the answer. 3 marks. Okay. So that is, we try to find if, okay, if the standard deviation, of the samples, just now it is 500. So plus minus, sorry, not plus minus, this one, which one is it? This one. Okay. So the sigma here, the standard deviation, okay, for sample, okay, that's for sampling distribution. Okay, the sigma for sampling distribution is 730.3. So this one is 4,000 out of n. Okay, and sample size of 30 is 730.3. Okay, so what if instead of 30, n, instead of n is 30, meaning that you took out 100 sample managers to be your sample, 100. Tadi 30, just now it was 30. Now it is 100. So what you will get is the standard deviation of 400 here. So you put that here. Okay, the plus minus 500 is still the same. Okay, so this one still 71,800 and 71,300 and 72,300. So this is regarding the n. If you took 100 managers instead of 30. So the possibility or the probability. So you go to Z-score 1.25. 1.25. Ni kan? 0, 1, 2, 3, 4, 5. Okay. 0.1056 and 0.8944. Okay. So you have 9472. Saya salah tengok ke tadi? Okay, tak apalah. So yeah, I think I took the wrong column. Never mind. Okay, so you have the answer is 89%. So can you see the difference? This one here, if your n sample, okay, the sample that you took out is 30, okay, 30 managers. This is your sample of 30. The probability that you will get the average salary within plus or minus 500 population mean is 50%. But once you take more, you increase the sample from 30 becoming 100, now the probability is even higher, 89% compared to 50%. Okay, so you have the sampling distribution of P bar. Okay, P bar is actually bukan P bar, sampling proportion, sampling distribution, the proportion of this one is equals to P. The same thing, it's the same thing here. So we go back to binomial condition. So you have n times P equals to or bigger than 5, minus 5, and so on. So this is the what do you call it? Okay? Probability of obtaining P bar within 0.05. So we know that this one here, tadi 0.6. I think it's given to you. Yep. Another one. 0.6. Okay. So the P bar for the population proportion is 0.6. Okay. So now the question asks, what is the probability if it is plus minus 0.5 within the proportion, the proportion of 0.6. Okay, so 0.05 within, plus minus lah, plus minus 0.6. So tolak, subtract minus 0.6, you will get 0.55, plus 0.6, you will get 0.65. Okay, before I continue, I don't know whether you guys are there. So let me ask question. Can you understand so far? Guys, are you still there?
Yes.
Okay, thank you.
Yes,
Just want to
Doctor.
know whether you are still around or actually you are looking at something, doing something else. Okay, I'm not actually what do you call it? Have any negative what do you call it? Yeah, something wrong with my um how I think tonight. But never mind, we are going to finish this anyway. Okay, so it's the same thing. Okay, so you have all this here, trying to find the P bar. Okay, so you have here Z score. So still we are looking at Z score. So we will use Z table. Okay, tak ada masalah. And then there are a few things here that you need to understand. The sample statistic theta. Okay, theta is unbiased hat theta hat. We have the hat atas tu you have like a small one. So this thing is a theta and you have a hat over there. Okay, so you have a bar meaning that the straight one. So you have something like this. This is what we call as hat. Okay, so this is a theta. So you have sigma, you have alpha, you have theta. Okay, so these are all what we call it as a um, uh, I wouldn't say this is not a function, but it's more like it will help us to understand more if you need to calculate. So okay lah, tak apalah, tengok je lah. Okay, so consistency. Okay. So finally, so you are going at sampling. So I did tell you that we need to find a sample. If we couldn't do any measurement on the population, we couldn't actually calculate for population because population is huge. For example, like I said, we have 17,000. We have 70,000 sorry, 21,000 including postgrad. So 21,000 OOPSI students. So you can't possibly ask or try to use the 21,000 to answer your survey, okay, or to find the answer for them. So what you will do, you will take sample, okay, random sampling. So random sampling, we have so many ways of doing the sampling. So you have the stratified and you also have cluster. Okay. So for example, you have stratified sampling. So stratified sampling is where you try to do in terms of it says here homogeneous, ada somewhere. Okay, that's why. If the strata is homogeneous, this method may provide results that are more precise. So what does it mean by homogeneous? Okay, homogeneous meaning that you are trying to you try to separate your population according to groups. Okay, cluster is also the same thing. Okay, but the difference is that this one here, for example, if let's say that you go for school, okay, let's say you want to find school student, you want to do some sort of trying to find whether they have the means to use Wi-Fi if at school to do an online class. Okay, let's say that online class. So what you will do is that you will say that, okay, I will try to separate between those who live in rural area, those live in the city. So our assumption is that those in the city will have better equipment or better gadget compared to those who live in rural. So you try to separate that. Okay, so that will be stratified sampling. Cluster, usually we go for in a way geographical area. So rather than go for rural and cities, okay, you go for each state. Okay, if let's say that you want to do for Perak, so you go for each district. So that will be cluster. Okay, all right. So you have systematic. So systematic is where you try to randomly take the first one from the population list and keep on taking one. Okay. Next, you have the non-probability sampling. So this one here, stratified sampling, random sampling. When we talk about random sampling, it doesn't matter whether it's stratified random sampling or cluster random sampling. We have or systematic sampling. These are all what we call as probability sampling method. So probability sampling method is where you can actually do some statistic and try to find out using probability sampling technique, the one that we have learned before. And we have another one what we call as non-probability sampling. These are not random. Okay, so these are not random. So what does random means? Random means that everyone will have the will be have the opportunity to be your sample. But when you do a convenience sampling or judgment sampling, then not everyone will have the opportunity to be the sample. Convenience sampling, for example, if let's say that you want to do on students, just now, you want to do on school student. So rather than you go to random, you go to this school, you have chosen, okay, you go for stratified, okay, you go for rural and you go for cities. So you have to go, okay, I'm going to the cities and I'm going to choose five school from the city, five schools. So randomly. So you will go to school and you choose randomly. And then you go to the rural area, you choose another five school. And then you will go to the school and take another random student to be your sample. So that is probability sampling. So convenience sampling meaning that you have a brother at home who are at school. So you ask him, be my sample. And please ask your friend to be my sample as well. And ask your friend of your friend to be your sample as well. And then you ask your mother. Let's say your mother is a school teacher. You ask mother, can I get your student to be my sample? Can you ask your friends who is another teacher to be, for their student to be my sample? That is convenient sampling. Okay, convenient to you. Okay, so that is not probability sampling. Okay, so another one is judgment sampling. The person most knowledgeable on the subject select element of the population that feel as more representative of the population. So you are going for the person you think is the most wise. For example, let's say that you go to the headmaster, something like that. So more like a judgment rather than a um, what do you call it, a random sampling. So you have a sampling error. So sampling error is the natural deviation from sample that result from random sampling. Sometimes when you do sampling, definitely there will be error. Okay, so when you want to do sampling, the ones that you want to reduce is the sampling error. There will be sampling error whenever you took sample. If you don't want any error, then you have to go for population. Okay, so error meaning that it does not actually result from error when you are doing your sampling. Okay, so this one, limit the impact of sampling error by collecting larger sample size. So the bigger your sample, the smaller your sampling error. Okay, so non-sampling error. So the sampling error, the error caused by your sampling. Okay, when you do your sampling, there's an error because of that. But there are things which not because of the sampling. Okay, so the types of non-sampling error is that coverage error. So you are supposed to do Malaysia. Okay, I want to find out the students in Malaysia. So what you will do, you go for cluster. No, you go for cluster first. You go for geographical. I want to go for the northern part of Malaysia, for example. So what are the northern part of Malaysia? So you have the northern part of Malaysia will be Perlis, Kedah, Perak, boleh lah Perak. So you have Perak. So what else we have there? Kelantan will be on the east, isn't it? Eastern side. So no, so you go for these three: Perlis, Kedah, and Perak. So that will be northern part. Okay. So let's say this northern part, actually you only go for Perak. You did not go for Perlis. So that will be a coverage area. Okay. And then you have a non-response error. When you are segmenting, the same as that one, there are some who did not answer your survey. Okay. And there are a few more non-sampling error. And then we have the big data and sampling error. Okay, so big data, I think you have heard of big data. So big data is where the data is so big. So that's why you call it a big data. Okay, too large, too complex to be handled by standard data processing technique. Okay, or typical desktop software. So big data usually, I would say that it only comes into the picture when we have the internet. You have the, for example, let's say that once upon a time there was an issue where they said that Facebook actually collecting data illegally. Okay, so when that happens, there are so, okay, let's say that it tries to see where, I think even now when there are some data collecting, that's why you need antivirus. What else do you have? Is it still antivirus? Security, some sort of security for your computer. Okay, so that you won't be spied on where you go, where you go on the internet. Okay, so I think one of the best way, if you can see, is that when you are using this e-commerce platform, Shopee, Lazada, sometimes you keep on, for example, like me, I always go for, I have 37 cats. So I always buy things for my cat, like from their toys, their food, what else? Their scratches, their toilet and everything. So whatever comes through my wall, usually it's about cat things. Okay, so these are how data were being collected. Okay, so for example, this is only one person, me, but we know that there are millions of people actually go online trying to purchase this and that. So data were collected at the time. Okay, so all this data, they are so immensely huge, so that is we consider as big data. But if you manage to have the data or the big data and do the analysis, then it will be most accurate compared to when you do the sampling things. Okay, this is also a sampling thing, because not all population will be there, but at least it captured, okay, the purchasing. Okay, your purchase. Usually big data is used for marketing. Okay, definitely marketing. Okay, all right. And this is a summary. Done. Any question? Guys, any question? Before we continue with another topic. Ada orang ke ni? 84. So what happened to another 11? 12 people. Okay, ada yang sharing Okay, never mind. Anyone? Question? No? No question? Mukri?
Okay.
Okay, Syazwan, okay. Saja sebut Mukri because his name is right in front of my screen right now. Okay, Kausalia. Alright, good. Okay, Tan. Okay. Okay, so if you don't mind, can we have one more chapter to cover? Okay, still the same topic, but this one here, a very short one. Okay, because there's only 23 slides. Okay, and from that 23 slide, 5 slides is already the one that we have, I have actually go through. Okay, so let's do the second one. Okay, let's do this again. Share. Okay, so we have the interval estimation. So this one will be a few. The first one is regarding the population mean. So we already know what is point estimator. Okay, so we have the sample mean of X for mu versus X bar, and then we have P bar, opposed to P. Okay, so we have here the interval estimate. Okay, so the interval estimate is computed by adding and subtracting a value, margin of error. That is what we call margin of error, or the plus minus. Okay, this one here, the plus minus. Okay, so X bar plus minus margin of error. P bar plus minus margin of error. So when we try to find, okay, so this is an example. So you need to know that there is a population mean, meaning that we have the population mean and the sigma is known. Okay, the sigma is known. Okay, try to find for him with the sigma is known, and we have another one. Okay, population mean when sigma is unknown. So we are looking at those two. Okay, let's see this one here. Mana dia? Ni. Okay, so you have the population mean where sigma is known. We have the population mean when sigma is unknown. Next, we will go how to determine sample size and then population function and big data tambahlah benda yang tadi ya. Okay, so we are going to calculate. Okay, so we have the population standard deviation, which is the sigma, and we have the sample, the standard deviation for sample, which is S. Okay, so this one here is if you know the sigma, okay, when sigma is known. Okay, so for example here, let's say we have the 100th customer, simple random sample, X is the amount spent per shopping trip, and S is the 20 ringgit, the standard deviation based on historical data. So calculation reveal the sample mean upon estimate of mu is X bar equals to $82. Okay, so you have this one here. Okay, you have the where you have the 20 S 20 divided by N. Okay, square root of N, and then we have equals to 2. Okay, this one here. Okay, equals to 2. So this sampling distribution shown that to the right depict how values X bar are distributed around the population mean. So this is the population mean. Okay, so we have here, it follows the 95% of the values of the normal distributed X bar random variable falls within plus minus 1.96. So 95% of all the values of X bar will be here, 95%. So don't ask me 1.96. Okay, so because it is given to you that this is actually the Z score plus minus 196. So you have here the mu is here. So you will have 1.96 is equals to 3.92, and you have plus 3.92. Okay, so we have this one here. Okay, so margin of error is 3.92. So X bar plus minus 3.92 here. Okay, so the first two interval built around the sample mean is X1 and X2, include the population mu, but the third one X bar 3 does not. So don't just understand that the confidence interval is 95%. So what I'm trying to show you here is the Z score. Okay, Z score of 0.02 Z equals to 1.96. Okay, so actually we are looking at another table. Okay, another table which one is it? T. Okay, this one. Okay, so that one is Z score. This one. Okay. Okay, 1 point minus is 2, 0.025. So Z alpha divided by 2 equals to 1.96. Okay, you can just check with your Z score table. Okay, so Z score table, I think you guys are already have no problem reading. So let's go to the one that I need to show you. Okay, the T. Okay, so T, we have another T table. This one here. Okay, so the critical values of distribution, this one here is what we call as degrees of freedom, DF. I don't know why this one is. So I usually use DF. So this one is V. Is it V? Okay, so DF, degree of freedom. Okay, so degree of freedom is N minus 1. Okay, and then we have the 0.05, 0.05, 0.025, 0.1, 0.05. So this one here, when you divide it by 2, you will get this one here. So 0.05 divided by 2 is 0.025. The same here, 0.1 divided by 2 is 0.05. So you will keep on dividing and dividing, and you will get this. Okay, all right. Okay, so okay, an interval estimate of population mean, which is mu, when sigma is unknown. So when sigma is unknown, then we will go for T. Okay, so it is given to you here. Okay, n equals to 70, and x bar is 9312, and sample stand S is 4007. So we try to find uh, this one here, T distribution when this unknown, sigma is unknown. So alpha divided by 2. So what you will get is this one here. Okay, so you will go for degree of freedom. Okay, so you go for degree of freedom, which is 69. Okay, and try to find 0.025. Okay, so I have found this one here. So the thing is, if you try to find T score, T table, so sometimes you don't have all this here. So you might not have 69 here. What you have is 60, 65, 70. Okay, but 70 is already close to 69. So you see that the number is the same. So the answer is, okay, so you have 1.667, isn't it? Just now, just say that because 0.05. Tadi. Okay, this one. So 0.05 is 1.667, but we go for 0.025 because alpha is divided by, so 95%. So 95%, 1 minus 95% is 0.05. Okay, but if you are looking only at half of it, only this one here. So 95%, you have to understand. What is it? Okay, this whole thing here is 95%. So 5% is here plus here, 0.05. 1 minus 0.95 is 0.05. So this one and this one is 0.05 plus. So if you try to find just half of it, only this part here or this part here. So 0.05 divided by 2. Okay, so this one here is 0.05 divided by 2, and this part here 0.05 divided by 2. So in the middle is 95%. So when you try to find the T, okay, from the table, okay, what the numbers, sorry, silap, sorry. Okay, so we know that the upper tail, this one here is 0.05 divided by 2. So what you will get is 0.025. Okay, so 0.025 equals to 1.995. Mana tadi? 69, 1.995. Okay, so some of the tables, like I said, they don't have, but you can see that you will have 70. So what you will get is almost the same. Okay, so 1.995 dan 1.4. Okay, dekat lah. Okay. Okay, so what you will have is that 1.995, 9312 just now. Okay, we have the X bar of 9312. Okay, 9312. And plus minus 1.995, which is this one here, and times with this one here, you should get 9312 plus minus 955. So thus, the 95, we are 95% confident that the mean credit card balance for the population of all household is between plus minus 955, which is 9312 minus 955 plus 9312 plus 955. So you get between 8357 and 10267. So 95% we are confident that it falls within that. So what happens if we do not want 95% confidence? We want 90% confidence. Say you have up here. So 90%, if let's say that we are trying to find, rather than 95%, we want to find 90%. Not 95%, just the 90%. Meaning that this one here will be 10 plus here 0.1, 0 plus 2, this one and this one plus will be 0.1, meaning that 0.1 divided by 2, 0.1 divided by 2. So instead of looking at 0.025, you will go for 0.05. Why? Because 0.1 divided by 2 is 0.05. Okay, so sama je. Okay, so it's something like that. So, but usually we'll go for 95%. Okay, all right. So these are, okay, so before I continue, can you understand that? Guys? I rather, the quietness is really suspicious actually. Hello guys, are you still around? Terus senyap ni. Yes. Are you guys giving me the thumbs up? Because I couldn't see you. Okay. Okay, tak apalah. Just continue on. Okay, so I know that you will understand more when you do exercises. So I will give you the exercises. So this is how you try to find. Okay, and so on, more popular and formula and formula. Okay, so this is the sample size determination. So how much or how many do we need? Again, there are some formula, okay, some formula which are involved. Okay, so you can find this out later and do the exercise. Okay, so how do you find this? Ni bagi thumbs up ni because faham ke apa? Ke sebab habis dah? Giving me the thumbs up. Okay, so ada beberapa orang yang tak hadir. So you will get the warning letter from me for sure. Okay, so guys, okay, ramainya. Okay, Vishnu, ramai banyaknya memang gini. Only a few people actually giving me the thumbs up. Okay, alright, never mind. Okay, so any question, guys?
No.
Laju. Okay. Thank you for the answer. Okay, never mind. So I will ask you to do some calculation on your own. Okay. A lot of exercises. If you don't understand whatever I'm telling you just now, you can go through the textbook and perhaps go through again the video. So because I did record this session, that's one. So the second one is regarding your class on Wednesday and Thursday. The truth is I don't mind having class on Wednesday, but the thing is on Thursday, we are supposed to be an online one. We're supposed to have an online or hybrid. But the thing is, it's not about the online or hybrid. The thing is, I'm not around. Again, I have to go to an event in KL on the 29th, which is from 8:30 in the morning until 5 in the afternoon. So 5 in the afternoon, meaning that I will only reach in Tanjung Malim around 7 plus. Okay, 7 malam. And I don't think at 9 o'clock I'm still that energetic to give you classes on Thursday. So my intention is for us to have class on Wednesday night. Okay, so do you have any problem having class on Wednesday night? Do you have any other classes that you need to attend? So Haini kata okay. Haini je 4 kali dia bagi. Muhammad Syazwan kata okay. Guys,
Okay.
any issue? Mukri berkata kata tadi.
Boleh.
Okay, thank you. Okay, so guys, we will have another class, online class nampak gayanya because kelas hari Khamis mungkin tak boleh masuk Our class on Wednesday. So we will have an online class on Wednesday and we will finish another 2. Rabu ni. Hari ni apa? Hari ni hari Senin kan? Sebab kelas hari Khamis ni tak ada. Bukan tak ada lah, saya tak ada 29 hari bulan. Betul kan? Hari Khamis 29 kan? Let me check. So I have 29, yeah. On the 29 I have to go to KL. Bank Rakyat panggil. Okay, so dah ada taklimat on this thing. So I have to go from morning till afternoon. So Khamis memang saya tak boleh buat kelas. Wednesday sepatutnya saya boleh buat kelas petang, tapi saya nak gabungkan you all dengan kelas hari Khamis. Okay, I want to combine you guys with Thursday because Thursday I won't be around. Okay, so we will have an online class on Wednesday night. Is that okay with you guys? Boleh Okay, so tak ada masalah. So this time around, I think we managed to cover as much as possible for this semester. Okay, I think finally we managed to catch up. Okay, so meaning that on Wednesday class, we might be able to do some calculation. Okay, kita akan buat sama-sama calculation. And if times permit, we will do calculation back from last week. Okay, last week, this week, bukan this week lah, today's punya class kita tak ada buat pengiraan. So I'm afraid that maybe you can't see the question or you can't see the concept there. All you see is the formula. Okay, so I will try my best for this Wednesday for us to do a bit of exercises. Okay, not just me giving you a lecture. Yeah, Najiha. Ada. Kita ada apa-apa ke? Tak ada kan? Anything? Tak ada apa kan? Tak ada apa cerita lagi kan? Tak ada cuti-cuti ke apa? Tak ada kan? Isnin yang cuti kan? Oh, iya ke? Raya Haji Oh my god. Bila Raya Haji? Oh, teruklah. Bukan ni ke? Apa nama? Ada apa nama? Agung punya birthday. Keputeraan. Agung punya birthday pula. Keputeraan. Isnin. 6 hari bulan. Oh ya ke? 6 bulan haji Oh my god. 6 hari bulan 7. Kenapa 6 hari bulan 7 ke 6 hari bulan 6? 7 hari bulan 6 hari haji. Cuba tengok sikit hari haji bila.
6 hari bulan 6.
6 hari bulan, Doktor.
6 hari bulan 6. So kelas kita 4. Ya Allah, kesiannya. Takkanlah hari Khamis saya nak buat kelas kan? Kejamnya. Kelas kita buat kelas online juga boleh?
Boleh, Doktor.
Boleh.
Seronok aja. Asyik kelas online je.
Boleh,
Apa cerita?
Doktor.
Okay, tak apa. Nanti kita buat some sort of kelas latih to be. Some sort, bila lah hari Sabtu ke bila ke, bulan 7 nanti ke sebelum exam you all bila? When is your exam? Guys, do you know when your exam is? Soalan jadual exam dah keluar kan?
10 hari bulan 7.
10 hari bulan.
10 hari bulan 7. Okay, let me see now. June, Julai, 10 hari Khamis juga lah. So never mind, we will have this, okay, apa-apa pun, whatever it is, I want to finish our topics because we are so far behind. Okay, so let's concentrate on finish our topic first. And then after that, once we finish the topic, we will have to do your group assignment, which I said, I think I already mentioned to you, your group assignment will be in the class. Okay, we'll do a physical group assignment where you have 2 hours to finish everything and submit. Okay, so your group assignment bukan jenis kena buat assignment, hantar, you go to AI, you go to ChatGPT, go to Copilot, asking for the Copilot AI doing your assignment. No, we are not doing that. So I will give you some questions where you need to actually solve as a group in the class. Habis masa kelas, you will submit. Okay, so it will take only 2 hours for you to do your group assignment. Okay, so that will be your group. But once we finish all the topic first, that's very important for me, and then we will do group assignment. So today we have covered 2 chapters, which is one equivalent to 1 topic. Okay, sekejap. Okay, so we have finished with this one here today. This one I finished here. So we have 1, 2, 3. So we have 3 more topics. So this one alone will be 2 chapters. Okay, again, so this one will be 2 chapters, which is on the hypothesis, and then you have the variance analysis. Okay, variance analysis and hypothesis will be 2 chapters from your book. So only one, it's a one topic but 2 chapters, okay? And then we have regression and correlation, also 2 chapters for one topic, which is we are looking at to be no, just go for coefficient, and then we go for regression, coefficient for correlation. And finally this one here, this one is a short chapter, okay, short chapter. So ni minggu ke berapa minggu ke 10 kah?